Okay, so hello everyone, thank you for joining. My name is Philippe and I'm the AI project manager at Wikimedia Deutschland, and I will be presenting the Wikidata embedding project. So first, I thought I'd start off with a quick introduction to Wikidata for the people who are not familiar with it. Oh, okay. So Wikidata is a free and open knowledge graph, one of the largest Wikimedia projects. So we're all familiar with Wikipedia, where you can write articles in your own style or own structure. But Wikidata is a more structured, more standardized way of storing information. So Wikidata has a set of items, which are any type of concept you can think of. Each item has a label and a short description. So for example, here we have an item for Douglas Adams. And what makes Wikidata a knowledge graph is that it has a list of statements. Each statement with a property. For example, here we have educated at and a value. Value can be text, numerical value, or even other items on Wikidata. So it creates this type of link between the data on Wikidata. And this linking, this connection of information makes Wikidata both accessible by humans, but also machines, where they can hop from one information to another and gather all the information that you need programmatically. So what makes Wikidata special? It's collaborative, you can be part of it. It's a more nuanced modeling of the world, as we saw earlier, and it focuses on verifiability, because statements on Wikidata can have references to external trusted sources. It's multilingual and it supports over 300 languages, and it's highly connected to a lot of external databases, from museums to books to cultural heritage resources to even other Wikimedia projects like Wikipedia. So we all know Wikipedia is basically a list of articles where humans can access the articles and read all the information on it. However, Wikidata is more accessible through machines. And one of the most popular ways you can access Wikidata's data is through Sparkle Query, which is a query language that allows you to do a lot of functionalities on the data, from filtering information to hopping through the properties, gathering and aggregating the information until you get what you're looking for, which is a table of your results. But now with the popularity of generative AI, we're looking into solutions to connect Wikidata with AI solutions, which tend to make use out of more textual information that is found on Wikidata and less on knowledge graphs like textual information like Wikipedia, but they don't make use out of knowledge graphs found in Wikidata. Okay. So why do we want to create this connection between Wikidata and generative AI? To better understand the reasoning behind it, I thought first I would share with you the differences between knowledge graphs and generative AI. So first of all, in terms of correctness, knowledge graphs have human verified information. They have explicit connections, they're more reliable. AI generates responses based on patterns and may produce errors. In terms of completeness, knowledge graphs can provide you with a complete list of information, exactly what you're expecting. But when you ask an AI model to provide you a full list of information, it would be limited to its recall and may miss some items. Knowledge graphs are easy to update with new data. However, AI models are bound to their training data, and it's difficult to retrain with more information. Knowledge graphs are transparent, their information is traceable and verifiable, However, AI models tend to generate information with non-transparent processes. We don't know, it's difficult to understand where response comes from. The only downside of knowledge graphs is that they require technical queries. You need to understand how Sparkle works, how to write Sparkle to be able to access the data. But with generative AI, it's simple to access with natural language interfaces. So this is where the Wikidata embedding project comes in. So the goal of the project is to create an open source vector database on top of Wikidata. And by doing so, by creating that new database, we enable semantic search on Wikidata. And we basically create that link between AI models and Wikidata. And by doing so, we also encourage the open source AI community to build projects with Wikidata. So by creating the vector database, by creating a link between generative AI and Wikidata, we then reduce misinformation, because in that way, generative AI models are referencing information from Wikidata rather than generating responses out of their weights or trained data, and therefore it minimizes errors. We reduce disinformation, because in that case, the AI model can provide users with sources of where the data comes from and links to Wikidata. So the user can then go back to the source and make sure that the generated response aligns with the data from Wikidata. We ensure freshness, because then the AI model is referencing up-to-date information updated by the community. And we amplify underrepresented knowledge, because in that way, contributing to Wikidata would have a stronger impact on AI, instead of creating a dent in the large amounts of training data that we don't even have access to. So what is the Wikidata vector database and how does it work? So to better understand the Wikidata vector database, I thought at first I would compare it with the Wikidata knowledge graph, which we already now are familiar with. So knowledge graphs are more structured. They have explicit connections between the data with the properties. However, vector databases are more unstructured and have disconnected data. Knowledge graphs are more used for explanations, for precise retrieval. However, vector databases are more used for exploration, for similarity search. Knowledge graphs have human-defined relationships between the data, and vector databases have more machine-learned mapping of the information. So what does that mean? What is machine-learned mapping? To better understand this, I thought I'd show you how we prepared the Wikidata vector database. So we start off by taking each item from Wikidata. For example, here we have the item for orange, the fruit. We pass it through a large language model, which then transforms it into a vector, which we can consider as like a mapping or a coordinate where the item would lie in the vector database. And the mapping is not arbitrary. It's basically takes into consideration the context or the meaning behind the item. So after doing so, after creating the vector database and mapping all the items on Wikidata to the vector database, we can see that our data clusters based on that meaning, based on their meaning. So we can see orange, the fruit, is clustered with other fruits. However, orange, the color, even though they have the same label, it's rather clustered with other colors. So after doing so, after creating our vector database, we can then perform semantic search. And the way it works is that we take a query from the user, either a sentence or a question or a statement. We pass it through the large language model, and it would be the same large language model, which will transform it into a vector, takes into consideration the context behind the query, and maps it to our vector database. And the way the semantic search works is that we consider the items, or it returns to you the items that are the closest in distance to this mapping of the question. And therefore, by doing so, we're extracting from the vector database Wikidata items that are the most relevant to the question. They might answer the question or lead you to a way where you can find the answer. So, I mean, for example, here you can see which animals can be pets, would link you somewhere around animals, around dogs and cats. So to better understand vector search, I thought I'd compare it with techniques that we're all familiar with, so keyword search, and Sparkle, which is the query language I talked about earlier. In terms of precision, keyword search is very precise because it gives you exactly what you're looking for if you're typing the name correctly. Sparkle is very precise because depending on whether you write the query correctly. However, vector search is a little bit more loosey. It may provide you with items that are not as relevant to what you're looking for. However, with this loosiness, this creates a scope for the vector search that is more wide. So it could be used for discovery, for exploration, for maybe finding items that you might have not thought of, but are maybe relevant to what you're looking for. But keyword search, for example, has a narrow scope because you're only finding what you already know, and you only finding what you're looking for. Sparkle has a wide scope because of all the functionalities that are available on Sparkle, from counting to passing through the connections in the graph and so on. In terms of ambiguity, keyword search struggles with that because it might provide you items that have the same label, for example, but have completely different meanings. Vector search can handle ambiguity because it takes into consideration the context of what you're looking for. And you can control ambiguity with Sparkle by adding more filters in your query, for example. The only thing that Sparkle struggles with is knowing the syntax, understanding how Sparkle works, but also understanding how Wikidata is structured in a particular domain and knowing the identifiers that you want to query on. But vector search and keyword search are easy to use because they have natural language interfaces. So we're not done yet, but first I thought I'd share some resources for the Wikidata vector database. If you want to know more about it, you can check out the Wikidata, the embedding page right here, or scan the QR code. And we have a UI for it if you want to query the vector database, and an API. So you can find them right here, or you can find them in the project page. And if you want to reach out for some feedback or projects that you're working on with the vector database, you can reach out to us with this email. So I wanted to share one more project that we've been working on, and maybe as I explain this project, you understand use cases of how to use the vector database and semantic search. And the project that I wanted to share is the Wikidata MCP, or Model Context Protocol. So Model Context Protocol is basically a standardized way for connecting your AI client or AI model with tools that you define yourself. So tools basically like functionalities, either to access external databases or perform all sorts of tasks, basically like functions. And because it's standardized, it's easy to set up, and you can basically switch the AI models with ones that are supporting MCP. So this is like a quick example of how it works. We have like a weather MCP that has a tool to provide like the temperature, let's say, and the AI model makes a call to the tool with some parameters, and the tool provides the AI model with the expected response. So in the case of the Wikidata MCP, the MCP creates a connection between the AI model and Wikidata directly to the vector database and to the Sparkle query service. So here are a list of tools that are supported by the Wikidata MCP. First, we have item search, which combines keyword search with vector search to provide the AI model with Wikidata items. So for example, if we search for Nobel Prize in Physics, keyword search gives you exactly what you're looking for and may also provide you with items that have similar labels. For example, here, vector search provides you with what you're looking for, but also since it has like a wider scope, it can give you examples that might be relevant for you. So in this particular case, it provides you with physicists that won the Nobel Prize. So for example, here, Nobel Francis Mott. Property search is exactly the same thing, but to find Wikidata properties. So we have this example right here. When we search for a word received, keyword search gives you exactly what you're looking for, and vector search gives you also properties that might be similar in meaning to the one that you're looking for. We have get entity claims, which basically lists you all the statements and values of a particular entity. So for example, if we search for the claims of Nobel Francis Mott, we can see that it gives you sex or gender, place of birth, and one of them being award received, Nobel Prize in Physics. We have get claim values, which is basically kind of like an extension to get entity claims, but it gives you more information. So it gives you references and deprecated values if they exist. So if you take the example that we saw earlier, Nobel Francis Mott, but we add to it award received, we can see all the values right here, and the one that we saw earlier, Nobel Prize in Physics. And we can see that it's referencing the official website for Nobel Prize, and it includes the date when it was retrieved. And finally, we have execute Sparkle, which takes generated Sparkle, runs it, and provides the AI model with either the results or an error message if it occurs. So if you want to test out the Wikidata MCP, I suggest you prompt the AI to follow a particular workflow. And the workflow that worked best for me is basically the following. So you can start with a discovery of example items using the vector search and keyword search to find items that are relevant to what you're currently looking for. And then use the explore statements. So basically using the get entity claims, get claim values to basically understand how these items are connected together in Wikidata in a particular domain. And after doing these two steps, then we hope that we provided the AI model with enough context to be able to build a proper Sparkle query. Personally, if I tried not providing, for example, the AI model with the workflow, and I noticed a lot of them jump directly to building a Sparkle query and assume a lot about the structure of Wikidata and assume a lot of identifiers. So it was not doing great. So after building a Sparkle query, we can test it out, verify if the results are satisfactory. If they are, then we're done. If they're not, then we can continue on the cycle until we find a good Sparkle query. So these are some use cases for the Wikidata MCP. One of them being Sparkle generation, which we just saw an example for. Another is question answering, which is kind of like the same thing, but providing the user with an answer from Wikidata rather than a Sparkle. Cross-database integration, because we've seen that Wikidata is connected to a lot of external databases. So it could be considered as like a hub connecting all these databases together and gathering all the information from these databases. We have fact-checking, which is particularly when using the references that are found on Wikidata, and a continuous research conversation, basically allowing the user to do follow-up questions, and like an ongoing exploration after a certain task is done. So this was the Wikidata MCP. You can read more about it in this Wikidata page or scan this QR code. If you want to test it out and connect it to your AI client, you can use the following link right here, but you can also find it in the Wikidata page. But make sure to add /MCP if you want to connect it to your AI client. And we have the email right here. This is all for today. I made sure to include all the QR codes in here if you want to look into the 2 pages. And yes, if there's anyone who has any questions, whether they're technical or non-technical, feel free to ask.
Thank you so much, Philippe. Yeah, so I think now we've allocated around 30 minutes, but we can go on a little longer if there's enough interest for question and answers. I need to remember to unlock everyone's ability to share their webcam. Really, it's over to the audience now. If you want to ask a question, you can raise your hand, and then we'll prompt you to unmute your microphone and ask away. We'll also be checking the Etherpad for questions that might have been written in the chat. So, yeah. Asela Abeya, would you like to unmute your mic?
Maybe
yes.
start the questions that were already posted on the chat and on the Etherpad, because quite a few people already lined up there. Cool. Philippe, first question I have here is Robert from Ed Summers. What representation of Wikidata items was used to generate the embeddings, and why was that chosen?
So you mean which items are currently available in the vector database?
No, how they're represented in the during the embedding, so the textification, basically.
Okay. Do I still have? Yes. Okay. Great. Because I have some slides for that. So yeah, we're currently working with an embedding model that is. We're not training our own embedding model, so we're using a text-based embedding model. So we tested different solutions of transforming a Wikidata item into text first, to then transform it into vector. And we found like if we transform it into more like human readable text rather than, for example, JSON or something else, that worked the best for us. So one example right here, it looks like that almost. There's a better example on the project page, but yeah, you get the idea. So you have like the label, description, and then the list of statements.
Great. Then we have a question from Finn. Finn is asking, I got early access to the Wikidata Embeddings Project API, where API secret was provided to me by email, and it worked fine. I suppose you will still need an API key. What should I do if there's a couple or more students that I would like to have the ability to use the embedding API?
So I'm happy to share that starting last week, you don't need an API key anymore. The vector database is fully publicly available. and it's the same same URL and API.
Excellent. Then I think next was Wotulo. What do you think? How many % of information is really human verified with similar quality standards, like in a good Wikipedia, like German, English, or French? And do you really think that it's easy enough to build up a community really to verify it?
I didn't fully understand the question.
The question was around how much of the information in Wikidata is actually well maintained by the community compared to Wikipedia in a large Wikipedia version.
Okay, that's kind of outside my scope. I don't have that kind of information.
Maybe I can say a bit to that. So there are right now about 25,000 editors on Wikidata, so people who make at least one edit in the last 30 days. There is, of course, a ton of content also. So more help is always appreciated. The good thing is that due to the close connection of Wikidata to Wikipedia, there are a lot of people who are both Wikipedians and Wikidata editors, so equally care about maintaining the data in Wikidata. And in addition, it being structured machine-readable data in Wikidata, there are a few tricks, like the constraints violation system we have, to make it easier to find problematic data. But that, of course, doesn't mean it's perfect, just like every Wikipedia has its flaws here and there. So more help, definitely appreciated. Then there was a question by Nicola, or rather a comment, to please share the slides.
We will do that, and you can also eventually find a link to the slides in the project page.
Yes.
Let me go back to the QR code right here. Okay.
Cool. Then people were asking for some practical examples.
So the vector database is like a very fresh. We just launched our first alpha version last week. So there's no, at the moment, projects that are making use out of the vector database. Feel free to experiment with it, build any type of project you might think of, and let us know if you build something interesting. But a few examples that I can think of, I have included a list of examples in the Wikidata embedding project, but the retrieval augmented generation is one of them, with all the positive reasons that I listed in the slides. But there's a lot of examples that could be outside of generative AI as well. So for example, simple classification, for example, is possible to do with the vector search. Classification, clustering, information, entity disambiguation, for example, and things like this.
Cool. Okay. Let's quickly switch to people who raised their hand. See, Wachter, do you want to ask your question? And then we'll get back to...
I hope you can hear me. I cannot switch on my video, but I hope you can hear me. So thank you very much first of all, for the great presentation, and congratulations to that project. I work in the field of digital humanities, and there we are always keen to know more about open link data, and provide our own data, and also create entries for Wikidata. And so this is why I'm interested in the way how the data is integrated into the vector database. Do you do that right away, or do you update the vector base regularly? So in other words, how long does it take to update the vector database with the data that I produce as a researcher, for instance? Thank you.
That's a really good question. Thank you for asking. So currently, we're still at a testing phase with the alpha release. We wanted to create this release to get people's feedback on the vector database and how well it integrates into other projects and how useful it is. And currently, the data that is included in it is from September 2024, when we first started the project. And currently, there's no like solution for updating the vectors. However, if everything goes well and we want to continue this project, then we would have solutions to update the vectors. And for now, what we're considering is basically updating on like maybe quarterly, every quarterly, updating the items that get edited and adding new items, because basically in general the vector captures a more like generalized understanding of the item, so small edits wouldn't make a huge difference in the vector level, and therefore it would be a waste if we make the updates as edits happen. So we thought more like a periodic update.
Thank you. Thank you so much.
Thanks for your question. Okay, then next question. NJ is asking if there's an API to query the vector database and or get embeddings. Yes, please see the links that Philippe shared. And then the second question from NJ is curious why this particular type of embedding was selected. Is it the result of some evaluation? What criteria is used to choose the embeddings?
Particularly the embedding model that we're using, I assume. So so basically we're using, to go to the slides right here. So basically we're using an embedding model provided by Gina AI, particularly the Gina Embedding v3. Basically we chose this embedding model for many reasons. One of them being that we're partnering with Gina and they're supporting us in many aspects, from providing us with an API to be able to create the project, and supporting us in developing the whole system. Particularly we're using that model from them because it's multilingual and it understands over 100 languages. And yeah, that's mostly it for that particular reasoning.
All right, then we have a question from Andrew. Are there rate limits, or what is the large-scale usage policy?
There are no rate limits in the sense that because the querying the vector database is completely anonymous, we're not taking into consideration your IP or any type of like email or something like this. There is a rate limit in the sense of having like 10 queries per minute, so that we just avoid spamming, but that's mostly it.
All right, then a question from Luana. Which model is being used to generate the embeddings? We covered that from Gina. Are there any biases we should be aware of?
Biases in terms of it's a really good question. It's a little bit difficult to measure this, mostly because the embedding model that we're using is trained on a lot of data even outside of the data from Wikimedia. So it's we should always take into consideration that there's this bias into consideration. But at the same time, the whole goal of the project is to provide AI projects with Wikidata items rather than responses or answers. Therefore, all of the information that is provided to the AI models are, at the end of the day, the up-to-date information from Wikidata.
So in that sense, at the very least, the biases that Wikidata has inherently.
Exactly.
Then next question from Hujmedin. If we need the vector database itself to run an application like Wikinews Pulse, ask about how can we have full access to it?
The vector database is publicly available. The API is publicly available. You can find the link for it in this Wikidata page. And the documentation is also included in there for the API.
Then how often is the vector database updated? We already covered that as well. Then, amazing username, I love it. Strange Camel Dancer is asking, what is the best way to get involved in the project? What would be the most helpful? Is there a prioritized list of tasks to pick?
We want to keep it open. We want to let people create whatever they can think of with the vector database. Any type of project that might be interesting for you. What would be helpful if you share what you worked on, so that we can see what people are working on and improve as we go, and see what's interesting for people. So you can reach out to us in this email, and there's also a user survey that you can take, that you can find in the homepage for the vector database. You can find it in this project page here.
Great. I think Hujmedin wants to talk to clarify the question that he had. Go ahead.
Hello, everyone. All right. So what I was talking about is about having the full access of somehow a file format of the vector database that can be stored somewhere in a server and used to drive an application.
Mm-hmm. Yeah, that's a good short question. We're working on that, actually. We want to provide the vectors, we want to make sure that there's a solution for you to download the vectors as well and recreate the vector database locally. Currently, it's not available, but it's something that we want to work on. And part of the reasoning, or part of what we're considering right now, is whether it's it makes sense for us to provide users with generated content. And vectors are generated content, but they're not content in the sense of like consumable content like text or images. But that's something that we're looking into, and hopefully we can provide that before the end of this year.
All right. Then the next question is by N. Are there already thoughts on ways to utilize MCP to contribute data back to Wikidata?
That's a request that we've gotten before, and I mean, currently you saw that the MCP is only for access purposes. It doesn't make edits to Wikidata, and we would like to keep it that way because we want to make sure that the data on Wikidata is only human created and not AI generated. It makes sense. You can still use the MCP for helping you in editing Wikidata, but then you have to personally go and make the edits yourself instead of allowing the AI to make that. Maybe a reasoning behind this is that model collapse is real, and we want to avoid that. Which basically, what model collapse means is that AI models are being trained on AI-generated content, and if this cycle happens and AI then creates data and then gets trained on that data, like eventually we reach a point where AI starts to collapse, provide completely wrong answers, and be completely useless. So we want to avoid that and want to make sure that Wikidata is only human generated.
Yeah. All right. Then the next one is by Berbel. How much effort was required to create the vector database? Do you think the workflow for creating the vector database can be reused for other Wikibase instances?
So it depends on the size of the Wikibase for sure. With Wikidata, currently with 30 million items, it takes around, let's say around 2 or 3 weeks to be able to, at least from our side, from our resources, to be able to create the embeddings and create the vector database. Yeah, one of our future plans is to make the vector database also available for Wikibase instances. We're considering more of like an extension where people create the vector database themselves with their own embedding model or their own infrastructure, but we make it simpler with an extension. But that's something that we would consider in the future.
Yeah, and it's definitely something that we will look at, right? Like we do want the Wikibase ecosystem to be flourishing, and if we have useful stuff for Wikidata, we will strive to move that also beyond. Then Alex is asking, can I use the Wikidata MCP as a tool in N8N? I don't know what N8N is, and connect it to an agent in order to improve LLM responses.
I'm also not sure what N8N means, but it makes sense because you can connect it to an agent. But yeah, I'm not sure.
Jaren helpfully shared the link, n8n.io. It's a node code tool, apparently. Thank you, Jaren.
Thank you.
Okay, then Andreas is asking, on what infrastructure do you run the embedding creation pipeline?
The embedding creation. So we're using the Gina API for creating the embeddings themselves, but then we have like a script on the side we run locally that uses the API and then uses another API to push the vectors to data stacks, the vector database infrastructure, and yeah, that's mostly it. So it could be run locally if that's the question.
Okay, then Andrew has another question. Is the natural language text ingested into the model only in English? What languages or options in this regard have been considered?
Good question. Thank you for asking. So I have a slide for this. So currently the way we create the vector database is that we transform each item in each language into a vector. So we have, for example, you can see here the item for Maya Angelou. We take the information in English, in German, and French. Each one of them is a separate vector on its own, and all of those are pushed to the vector database. Currently, we created vectors for English, for French, and for Arabic. And we will add more and more languages as we develop this further. The reasoning behind this is that there's a lot of reasonings. One being that there's a lot of items that are supported outside of English, for example, and in other languages. We want to make sure that those are included in the vector database. Another reasoning is that we saw if we're combining all these vectors into one vector database, we noticed that the accuracy actually improves. So there's it's as if like the diversity in those different languages are creating a more enriched vector database. And also creating this one vector database and creates more possibilities for other solutions. For example, if we compare the vectors in different languages, maybe that's like a project, for example. We haven't tested that, but maybe that's an idea.
Philippe, do you maybe want to talk about people contributing these transformations for their languages?
Yes, for sure. So one way we're transforming an item into a text format is that we're using templates per language to be able to do that transformation. This looks a bit straightforward. I don't have like a good example for this, but maybe I'll just say, I'll just talk about it. So for example, in English, we say like label, Maya Angelou, the description, and we say like also known as, and then all the aliases, and a lot of like nuances that make sense in English. And we have a template per language. So if people want to contribute, you can find the templates on the GitHub page that is linked to the project page, and you can verify if the templates make sense in your own language or the language that you know, and add more templates if there are languages that are currently not supported.
And one great way where to contribute this is potentially wiki functions. We're gonna be talking to the wiki functions team about potentially using the functions that are being created there to help with this transformation. Then we have a question from David. I see I can use the vector database interface for reconciliation when I enter an entity name and some context. Can I specify what class of item I'm looking for, like a person, a place, or a building?
So if you look into the documentation, there's currently one additional filter to the retrieval of items or retrieval of properties. This may be too much details, but one filter is basically filtering or getting the items that are instance of a certain Wikidata item. So you could do a search only on instance of human, let's say. Yeah, it's available in the API. You can test it out and let us know if that's something useful for you, or if there's additional filters that you might consider.
Amazing. Then Sache is asking, again, are you planning to publish the vector data as a downloadable file?
Yes.
So it could be imported to some other database locally.
Yes, we talked about this, but yes, we are considering to do that, hopefully before the end of this year.
Okay, then Rezifu is asking, isn't it a concern to use DataStax as the vector DB since IBM has acquired it and we never know what Big Blue is planning to do with it in the future? Has there been other candidates, and if yes, why have they been sorted out?
Yeah, that's a good question. So DataStax have been really supportive in building this project. it would have been very costly, and we don't have the resources to build it ourselves, and they were happy to provide us with the infrastructure for free. So that's why we're working with them and doing this collaboration. There's no particular issue in terms of, like, let's say, the data transfer or something like this, because all of the personal or like queries or personal data are only stored and only passed to our API, but not directly to DataStax. DataStax is only considering the data found on Wikidata.
All right. Then Chris is asking, how many gigabyte of data is the vector database?
Hard to say. Last time I checked, I think it's around like 800 gigabytes. Yeah, it's hard to say, but I think around that. And that's only considering like the, it's also considering vectors and the textual representation, not just the vectors themselves. When we want to publish it, it will be only the vectors, because like text representation is easily recreatable.
Excellent. I believe I covered all the questions in the Etherpad and chat. If people have more questions, please do post them or speak up. While we wait for more questions, Philippe, is there something curious you've already built with the vector database? Like a little game.
Okay. Yes, I wish you like told me that you wanted to ask this question. I would have like showed something in the slides, but yeah, I tried like as a fun little game I created with the vector database. It's if people are familiar with Contexto, you can look it up. It's basically like there's like a hidden word that you want to try to find, like you try to type words and see if you're close to that word or not. And yeah, you can try it out. It's really fun. So I built something similar with Wikidata, Wikitexto, where there's like a hidden Wikidata item, and you try to find it by guessing Wikidata items, and we find similarities with the vector database.
Cool. And sorry for putting you on the spot. We have a question from Matt. If in 5 years MCP becomes the preferred way for people to use Wikidata, is there any concern or implications for updating Blazecraft that powers Wikidata query service?
The MCP is only like an access path to Wikidata. It's still taking into consideration Sparkle and vector database, as we saw, and keyword search, everything that is already available in Wikidata. So I wouldn't say it wouldn't create any different change. It's only like making those all the access, like data access points on Wikidata, making them available to the LLM.
Cool. Then Chris is asking, what were the costs of the embedding and how long did it take?
How long did it take to create? So creating the vectors with the resources with the API from Gina and the API from DataStax, it takes me around. I mentioned 2 to 3 weeks. That's per language, and to push all Wikidata in one particular language to the vector database. And this is done while reading not with an API from Wikidata, but rather actually it was with the Hugging Face dataset that I published for Wikidata, which is like skipping a lot of steps of like finding all the labels of items as you're transforming the text. Yeah, cost. It's hard to. Yeah, I wouldn't. It's. I mean, with the APIs that you're using, it would be way different than if it was if you're doing everything locally, and it would be hard for me to estimate if it's if things are done locally.
Cool. Nicola is making a very important shout out. If you're building something with the embedding or the MCP, please do talk about it. We and everyone here would love to hear about it. Excited to see projects that people are going to build with it. Then we have a question from Michael. Using the tool on wd-vectordb.wmcloud.org seems to give slow responses. I guess that's not because the extra search takes this long.
No, it wouldn't make any difference if the search query is short or long. It's going to be the same thing. Yes, currently they are a little bit slow, and sometimes it. Yeah, we're basically working on that. We just need to add more resources to the current infrastructure.
Cool. And the very important question by Finn. Do you plan to embed lexicographical data, lexemes, forms, and senses?
I didn't consider that only because I don't know if what is the use case of it. Happy to share if someone has any idea, or like happy to hear about it. But yeah, I mean, if it's something that people are asking for, maybe that's something that we can include.
Nicola is saying, yep. But yeah, some examples of what you would love to build with it would be very cool to hear. Cool. Then setplace is asking, what is the perspective for adding smaller languages in terms of projected timeline, as in later in 2026 or later?
Can you repeat, sorry?
What is the perspective for adding smaller languages in terms of projected timeline? Late 2026 or later?
Yes, it's hard for me to give a timeline on this. We want to focus on more underrepresented languages, actually, because this is where the vector database would be more interesting rather than just adding the languages that it already supports, and it would be kind of a copy. Yeah, that's something we want to look into, and yeah, it's hard for me to give a timeline, but I would like, now we have 3 languages. I hope we, like, in the next few months we would add 3 more, and so on.
Great, and people are starting to come up with use cases for embedding lexemes. So maybe something around pronunciations, text to speech, and vice versa, or giving it a sentence from a text and asking for the sense of a verb used in that sentence. Also around pronunciation, as in IPA. Is this text a poem? Does it rhyme? Let's see.
Sounds interesting.
Cool. We are at the end of our time, but if people have more questions, I'm sure we can do a bit more, but I think I covered everything that I've seen in chat and Etherpad. If not, please raise your hand and let us know. If not, Danny, do you want to wrap this up?
Sure. Yeah. Thank you, everyone, for coming and being so diligent in writing in the chat, leaving your questions. It was really great to see how many questions we had. Thank you, Philippe, for the lovely presentation, and Lydia for remaining so calm under pressure and getting all those questions recorded. I realize I completely forgot to introduce Lydia, Sanjin, or myself at the beginning of the of the introductions. So here we are. Yes, hello. I think we don't see much in the chat apart from some shout outs. We've been asked by our communications team to get some quotable sentences. So if you have anything nice to say, please go ahead and write it now. We'd love to hear about it. Or you can leave any quotes in the Etherpad as well. But yeah, we're going to link the slides from the event page, and they'll also be available on Commons. And when the recording is done, which I assume it will take a couple of days, maybe early next week, you'll also be able to find it on the Event Embedding Project webinar page. If you'd like to stay updated about what's happening, we do have the Embedding at wikimedia.de email channel, but I don't believe that's a subscription list or a distribution list. So if you've registered to the event to join this webinar, then we can use that to send you an email later. And if you don't want to receive updates, just unregister from the event and then you will be unsubscribed. I think that will work. Yeah. Thank you again, everyone, for attending. Do we plan to have another one of these at any point? Is there any plans for another one?
Not that I'm aware of, but hopefully.
Yeah, let's hope so.
Maybe the next one can be a showcase of the things that people built.
Oh,
that would be fun.
Yeah. I look forward to that on our social media campaign. Then I think it's really just left for me to say thank you, everyone, and say goodbye.